All right, test, test, test. It seems like my audio is working. Don't think anybody is going to see this right now, but I am going to go live just because I am still working. Sorry about the noise in the background. That's my washing machine, and I do not have a camera hooked up right now. So you're just going to see my screen. All right. This was sent to me from pub.med.gov or pubmed.gov. You'll see the link up here, pubmed.ncbi.nlm, then .nih.gov/331-91178. The title to this article, it looks like it was published in the this journal here on November 3rd, 2020, which I'm not sure about that because they're talking about something that it could have been, I guess, published then. All right, so what the title of this is, chicken egg yolk antibodies, IgYs, block the binding of multiple SARS-CoV-2 spike protein variants to human ACE2s. All right, the abstract to this article, and I'm showing this on my screen here so you can read along here. Let me make that a little bit bigger for you. Abstract: the SARS-CoV-2 virus is still spreading worldwide, and there is an urgent need to effectively prevent and control this pandemic. The study evaluated the potential efficacy of egg yolk antibodies, IgY, as a neutralizing agent against the SARS-CoV-2. We investigated the neutralizing effect of the anti-spike S1 IgYs on the SARS-CoV-2 pseudovirus, as well as its inhibitory effect on the binding of the coronavirus spike protein mutants on the human ACE2. Our results show that the anti-spike S1 IgYs showed significant neutralizing potency against the SARS-CoV-2 pseudovirus, various spike protein mutants, and even SARS-CoV in vitro. It might be a feasible tool for the prevention and control of ongoing COVID-19. There's keywords, a couple graphs, and so forth. All right. Now what we're going to do is I'm going to get the full text of this. I won't read that abstract to you again. So we'll go to the introduction. Introduction. The ongoing COVID-19 pandemic caused by severe acute respiratory syndrome, coronavirus, SARS-CoV-2, a novel strain of coronaviruses, has rapidly spread and evolved since the end of 2019. To date, SARS-CoV-2 accounts for more than 40 million infections and more than 1.1 million COVID-19 related deaths worldwide. Worrying, there are still no available vaccines or antiviral drugs against the SARS-CoV-2. Previous studies have demonstrated that the spike S glycoprotein homotrimer, I don't know how to pronounce that, homotrimer, on the surface of SARS-CoV-2 plays an essential role in the human ACE2 receptor binding and virus invasion. Therefore, neutralizing antibodies against SARS-CoV-2 spike glycoprotein present the most promising approach against COVID-19. Besides, several neutralizing antibodies that target the receptor binding domain, the RBD, of SARS-CoV-2 have been isolated from convalescent patients. Despite the advancements, the use of monoclonal antibodies in the treatment of COVID-19 faces a wide range of safety threats that are yet to be addressed. Now, my commentary on that is we've seen that to be not true since the writing of this. Besides, the high production cost and low yield might complicate the use of the neutralizing antibodies, especially in the developing world. Therefore, there is a need to explore other strategies that might be more economically suitable and feasible in the fight against COVID-19 prevention and control. The first report about egg yolk antibodies, IgY, as a neutralizing agent against the tetanus toxin was published in 1893. 3 years later, Beering and S. Chiazzato discovered the diphtheria antitoxin, the 1901 Nobel Prize in Physiology and Medicine. The use of IgYs did not gain clinical significance and wide application until the advent of the 3 R's principle that was first described by Russell and Birch in 1959. The IGYs gain more attention for their stable chemical properties, low cost, high yield, and improved animal welfare. More importantly, the IGYs neither bind the human rheumatoid factors nor activate the human complement system, which minimizes the risk of inflammation. Which that's essentially, I think, saying that people are generally not allergic to eggs. There are some people with egg allergies, but generally they're not. As a passive immune agent against viral and bacterial diseases, IGYs have the potential to make functional foods and new drugs. Several IGY formulations have been approved to treat goose plague, duck plague, and other diseases by China Veterinary Pharmacopoeia. IGY antibodies have also been applied to combat human viral infections such as the respiratory syncytial virus, RSV, influenza virus, and Coxsackie virus. In one study, anti-SARS coronavirus IgYs were purified from chicken that were immunized with inactive SARS-CoV coronavirus, and the IgY antibodies were able to neutralize the SARS coronavirus in both vitro and in vivo. Here we purify anti-spike S1 IgYs from hens that were immunized with the S1 domain of the SARS-CoV-2 spike protein and interrogated their ability to neutralize SARS-CoV-2 pseudovirus using HeLa cells with overexpressed human ACE2. In addition, we use competition ELSA assays, I don't know what that is, to validate the IgY's competitive binding to various SARS-CoV-2 spike protein mutants, as well as the SARS-CoV spike protein. Materials and method, let's see what this goes to. Doesn't go anywhere. Okay, so there is no materials and method. There is the, or never mind, it's 2. 2.1, preparation and quantification of anti-S1 IgY. A DNA sequencing coding S1 of SARS-CoV-2 spike protein was codon optimized and synthesized by GenScript USA Inc. The gene was then subcloned into a PFAS BAC1 vector for insect cell expression using the BAC to BAC baculovirus system. Great, they're gonna put them in mosquitoes. That's awesome. All right, that's what they were talking about like a week or two ago. We'll just inoculate the mosquitoes and send them out there to inoculate people. No movie was ever made about stuff like that. Anyways, the codon optimized SARS-CoV-2 spike 1 S1 was expressed in SF9 insect cells using the baculovirus insect cell expression system. Excuse me. The purified recombinant SARS-CoV-2 S1 protein was mixed and emulsified with Frunz immune, what is that? Adjuvant, I don't know what that is, in equal volume, and then used as an immunogen. Each hen was injected intramuscular with 150 micrograms of recombinant spike protein under the wings for once a week for 4 weeks, and then IgY was extracted and the titer evaluated. Here we adopted an improved extraction as described by Sok Huitan with slight modification for subsequent processing. We removed the lipids and lipoproteins and then precipitated the subnatant with a final concentration of 15% cold ethanol instead of the ammonia sulfate. The purity of the extracted IgYs was more than 80% without ammonia sulfate residue, and the process took less than 2 hours. Moreover, centrifugation could be replaced with filtration, which makes the extraction process more suitable for large-scale industrial production. The extracted IgY titer was quantified by indirect ELSA. I'm not sure. I think ELSA is a protocol. I may be mistaken on that though. Briefly, the ELSA plate wells were coated with the recombinant SARS-CoV-2 spike RBD protein expressed in the HEK293 cells. Then serial dilutions of the IgYs were added to the wells at a 1 to 10,000 dilution of HRP conjunctant. A goat anti-IgY antibody was added. So I think I get the gist of that. But essentially, they're injecting the chickens, letting it incubate in the eggs or in chickens, pulling that back out, and then they can extract it via filtration versus spinning it using ethanol. I'm surprised ethanol or the ammonia sulfate doesn't kill the virus, but it does say 15% ethanol though. 2.2, the pseudovirus neutralization assay. The blocking potency of IgYs on the SARS-CoV-2 pseudovirus was evaluated by luciferius-generated luminescence. Here, HeLa monoclonal cells with overexpressed ACE2 were infected with the lentivirus carrying the SARS-CoV-2 spike protein and the luciferius reporter gene. That's the GenSkip company, Nanjing, China. The IgY's ability to neutralize the antigen was evaluated by performing the pseudovirus neutralization assay as reported by the luciferius reporter gene. 2.3, competition ELSA. We use the competition ELSA to evaluate the ability of the IgYs to inhibit binding of 8 different coronavirus spike protein mutants, including 7 SARS-CoV-2 spike proteins and 1 SARS-CoV spike protein, to the human ACE2. The SARS-CoV-2 RBD or RBD mutants were incubated overnight at 4 degrees Celsius in high bind 96 well plate. I think this is part of that ELSA protocol. A serial dilution of purified IgY to the 0.3 nanograms or per well were tagged human ACE2, and there's a category number. Were added to the coated plate and then incubated for 1 hour at 37 degrees C. HRP conjugated anti-human FC, which is 1 to 20,000, and it gives you another category number, was added to the secondary antibody. The OD450 were read by plate reader. All data was analyzed using GraphPad Prismate. So all this section 2 pretty much is just saying how they conducted the experiment, how they got the how they grew the CoV-2 spike proteins in chickens, how they extracted it, how they clarified it, and then the types of plates they were putting on to grow it again. All right, so the most important part here, results. Part 3. The results showed that the ELSA titer of IgYs reached 2 after the 3rd booster. The pseudovirus neutralization assay data showed that the IC50 values for the anti-SARS-CoV-2 IgYs was 270.5 micrograms per milliliter, with maximization inhibition of 75.86. On the other hand, the control IgYs had no obvious inhibitory effect, indicating that the anti-SARS-CoV-2 IgYs had a neutralizing activity. However, compared to the reported monoclonal antibodies, the IC50 value for the IgYs was relatively high. We associated this phenomenon with the fact that, like other polyclonal antibodies, only about 10% of the IgYs specifically recognized SARS-CoV-2, and the proportion of the IgYs